Hey guys, how you guys doing today? Welcome to another class lesson live straight from my living room. Today we're going to actually go over independent and mutually exclusive events. This has more to do with probability, obviously. So today we're just going to go over some simple things just to help you guys understand the process of how to differentiate between independent and mutually exclusive events. Okay, so now just so you guys know, and I'll put it in the video, mutually exclusive events cannot happen at the same time. They cannot happen at the same time. Meaning, for example, you cannot be good and bad. You have to be one or the other, right? So that's a mutually exclusive event. Like, you can't be good and bad at the same time. It's weird. It's like a Sour Patch Kid. You're first you're sour and then you're sweet. Okay, so that's a pretty good example. They're sour and then they're sweet. They can't be sour and sweet at the same time, right? So a good example, I guess you would say, would be a Sour Patch Kid, right? So, but I'm going to go ahead and be more detailed in my explanation of this here, dealing with certain examples. All right. So, if you ever wanted to check if something is a mutually exclusive event, all right, and this is the formula you would actually have to use when understanding mutually exclusive events, you would see if the possibility of event A and, I'll put the and sign, and event B occurring, they have to equal 0. So my example would have been a Sour Patch Kid, right? A Sour Patch Kid, right? A Sour Patch Kid, right? The probability of being sour and sweet at the same time means that it's never going to happen. That there's a 0% chance that's going to happen. You can't have them sour and sweet at the same time. It will be sour at first, then it will be sweet. Okay, so it doesn't come into, don't coincide with each other at the same event at the same time. All right, so that's just that. This is the formula you have here, right? Which is the probability of A and then the probability of event B happening at the same time. It doesn't exist. It's 0. So that's what you call mutually exclusive. They're of difference of each other. Okay. Now do not confuse that with an independent event. An independent event is a little bit different. All right. And I'll go ahead and give you some examples. Independent event it's written a little bit different when it comes to understanding. So this one was, as I said, mutually exclusive, right? This one mutually exclusive. So you have independent here, independent event. All right, and sorry for my scribble here. That's just how it's going to be looking like for now. All right, so it's the probability, right, of event B given event A, right, where this event B of given A has to equal the probability of event B of happening, right? So it's saying that the probability of event B occurring given event A is happening is equal to the probability of event B. All right, and I'll give you an example to that. All right, y'all, let me go ahead and give you guys some examples, some basic examples, simple examples. That'll probably help you out a little bit here. Now, here, I gave you guys some reminders here. I put them up here. So this one here is mutually exclusive formula, and this one here is the independent formula. Okay, so let's go over this example. If I ask you, say, are a red card and a spade independent of each other? Now, I'm going to first ask you this question. Are they independent? Do you understand that there's an independence between them? Remember, I told you here that an independent event, in order for it to be true, that the probability of event B given event A, they have to equal the probability of event B occurring. All right, so let me just break this down to you guys. In this case, you're going to look at this. A red card, well, is talking about a deck of cards. So there's 52 cards in a deck, right? 52 cards in a deck, right? All right, and then there's 4 suites in a deck of cards. There's diamonds, there's hearts, right? And then there's spades, and then there's clubs, right? Which these two are 2 red colored suites and these 2 are 2 black colored suites, right? Now, if there's 4 different suites out of 52 cards, that means there's 13 of diamonds, 13 of hearts, 13 of spades, 13 of clubs, okay? So now this is asking you specifically this. It's saying, what is the probability of event B, which is a red card, right? Given the probability of event A happening, which is a spade, right? So if I write this down for you here, this would be B and this would be A, okay? The probability of a red card given that there is a spade equals the probability of just having a red card, okay? Right? And this would be the probability of event B, right? So do you see here, when I matched it up with here, this is how they look, all right? So now here I'm gonna give you the numbers now. All right, so like I said, there's 13 of each card. So if there's 13 diamonds and 13 hearts, because they're red cards, okay, they're red cards, okay, you're going to get 1/2. All right, what that means is 1/2 meaning 13. I'm sorry, 13 and 13 is 26. 26 over 52 would give you 1/2. Okay, so that's actually the probability of getting a red card. Okay, so we have the probability. So our probability here, the probability here of whatever equals 1/2. Right now, like I said before, is there a probability of getting a red card given that is as a spade? Now, if you paid attention here earlier, a spade is a black card. All right, a diamond and heart is a red card. So is there a possibility of you getting that? No, there's a 0 chance, right? There's a 0 chance you will get that, all right? So there's a 0 chance that you'll pull a red card that is a spade because a spade is a black card, okay? A spade is a black card, okay? So now, given that explanation here, you will see that these are not independent of each other because these two events, these two probabilities here, they don't equal each other. Remember I told you these two have to equal each other in order for it to be an independent event. So therefore, being that the probability of a red card given that is as a spade equals the probability of a red card, it's 0 equals 1/2. So they're not independent, okay? So these two, make sure that you understand it's not independent. Don't mind my handwriting. Blah, 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 I'm gonna just scribble it on there. So it's not independent, okay? So it's hard writing sideways. This is just going to tell you guys that this example here specifically, they're not independent events, okay? Now, if you paid attention to what I said earlier, pulling a red card which is given that it could be a spade, all right, that is not possible, all right? So if you remember, this here, mutually exclusive, the next question here, we're talking about mutually exclusive events, right? So now, given the knowledge that you know now, you can automatically guess what the answer for this will be, all right? So we know that in order for this to be a mutually exclusive event, the possibility of event A and B occurring and B, meaning it happening at the same time, equals 0, all right? So we know, okay, that the probability of pulling a red card and a spade doesn't exist, right? This can't happen. This is what it's saying. This has to equal 0. So what it's saying, this doesn't exist. You can't pull a red card and a spade because spades are only black. The only red card you have is diamonds and hearts. So therefore, yes, it is 0. The probability of you grabbing a red card that's a spade doesn't exist. It's 0%. There's 0% chance. All right, 0% chance. And this would equal 0. So in this case, this is a mutually exclusive event. That's an E, not a C. Sorry, E. E, man. E. You know what I mean. All right. Oh, man, I marked my Halo marker. All right, anyways. Yes, so this is a mutually exclusive event. Okay, that's a very simple example. I will go ahead. Let's go with the next example. So the next two examples are this. Are the probability of a red card and an ace card independent of each other? Now, this one is probably a little more thought-provoking. Not really, but once I explain it, you'll be like, ah. So this one is explaining what is the probability of a red card being pulled given that there's an ace. Okay, now this has to equal the probability of pulling a red card. Okay, from the previous example, we already know what the probability of pulling a red card is. It's 1/2. All right, because like I said, 13 diamonds and 13 hearts gives you 26. There's a total of 52 cards in a deck. 26 divided by 52 is 1/2. Okay, if you want, I could write it out, but I think at this point you guys probably already know. So we can just write this P of whatever here equals 1/2. Okay, now when it comes to a red given that it's an ace, okay, now being that there's 4 different suits in a deck, therefore there's 1 ace in each different suit, so therefore there's 4 aces, right? There's 4 possible aces, right? And if I told you there's 2 red suits, then that means there's 2 red aces, so that's 2 over 4, right? If you simplify that down, that becomes 1/2 as well, okay? So therefore there is a 1/2 probability of pulling a red that's an ace card which equals the probability of pulling a red card. So if you look at it here, put that in parentheses as well. So the probability of pulling a red card, that's an ace, and then pulling a red card in general, are they independent of each other? If that's the case, do they equal each other here? Are they equal? Yes, they do equal each other. They do equal each other. So therefore, this event is independent. Relatively simple, right? So therefore, what about this one? Okay, now, the next question is, are they mutually exclusive? Now, if that means the probability of pulling a red card and an ace equals 0, like there's a, meaning, is there a 0% chance that would never happen? In this case, you know, you guys can probably use your common sense at this point, but I'll go ahead and explain some more. Are they mutually exclusive? So we know that there are how many aces in a deck of cards? Like I said before, there's 4 aces in a deck of cards, 1 ace per suite. But how many red aces are there? There's 2 red aces, right? So there's 2 red aces. How many total cards we have in a deck of cards? 52. Okay, you can reduce this down if you would like. It's gonna be 1/26, whatever the case is, but you know, this is fine here. Okay. Now, does this equal 0? It's saying that the probability of A occurring and B equals 0. It's saying that, is this possible? So A and B is a red card and an ace happening at the same time. You can pull a red card and an ace. That is possible. There's 2 opportunities for you to do that out of the 52 deck of cards, the 52 cards. So that is possible. That is completely possible. All right. So therefore, this event is not mutually exclusive. Okay. Mutually exclusive. All right. And here is your random fact of the day, guys. Random fact of the day for you guys today is a NASA suit. So a space NASA suit that you guys see them, you know, traveling all over the place with. That suit cost $12 million. Anyways, while the entire suit may cost $12 million, 70% of that suit cost comes from the backpack, which is a control module which basically harbors all the technology that they need to get done while they're in space and blah 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 blah, 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 all that stuff.
What's good? Yo, dog, understand me, say? Understand me, attack.